Please pause the video, read the problem. Let me discuss this. First one. Okay, here we know y has binomial distribution. N equal 30, p equal 35. N is the number of trials. P is the success probability. So you should understand this first. Then you should know the P probability mass function of what? Binomial. So this is n choose y, py 1 minus p, n minus y. So y goes from 0 to n, whatever n is. Here you know this problem y n equal 30. Therefore, this case y goes from 0 to 30. Okay, right. So then how do we find the probability y equal 10, exactly 10, right? You see that exactly 10%. Okay, right. So then here we need to use the PMF. Actually, we can use this one only for y equal sign. Okay, yes, here equal sign, you see. Yes, here also equal sign. Therefore, you can use this directly. N equal 30, y equal here 10, 30 choose 10, and p equal 0.35, power y equal 10, and 1 minus 0.35, 30 minus 10. Okay, so you can simplify this one. This is 0.150. Let me explain this one, how to simplify. That mean n choose y mean factorial n factorial y n minus y factorial. Okay, so this is 2210. Actually, please watch my video of the 2210 class, so then you will understand how to do it, right? So that is the probability. Exactly 10% respond positively, right? Next one. So next one is at most 10. At most 10. What is at most 10? That means probability y less than equal at most, right? 10. This one. Okay. Here actually not the equal sign, but you cannot use PMF directly for that case. We need to make it equal sign. So what are the y values? Y less than equal 10. You know y values are y equals 0 plus y equal 1. Similarly, up to probability y equal 10. So you have to write this PMF probability mass function for each case. So let me show you how to write for this one. N equal 30, choose y equals 0, then p equal 0.35, y equals 0, and 1 minus 0.35, 30 minus 0. Similarly, you have to write up to 10. So then you can get write down for each case and simplify. So then answer should be 0.508. I know it is a lot. So for the test, I am not asking that big like this, right? But I can ask at most 2, at most 3. Okay, something like that. Okay, the next part. So let me erase this one. So yes, go to the next one. At least 10. What did at least 10 mean? At least probability y greater than equal 10. At least 10, greater than equal 10. So then how do we do this one? Yes, because this is up to 30, therefore again actually you cannot use this PMF directly because this is not equal sign. So you can make equal sign y equal 10 plus y equal 11 up to probability y equal 30, right? So it is a lot of here, right? Bunch of numbers. So you have to plug this PMF for each case. But you can you can use the complement rule. What is the complement rule? Here you can use 1 minus probability y. It is not less than or equal, it is strictly less than 10. Why? Because this is a binomial, is a discrete distribution. Okay, it is a discrete distribution. So this is greater than or equal 10, then it must be less than 10, or you can write y less than or equal 9. Again, discrete. Okay, this goes from 0, 1, 2, then I say here 10, I say 9, 10, up to 30. So y greater than or equal 30 mean 10, 11, 12 up to 30, right? So what is the complement? Complement is start from 9. You see that 9, 8, then 2, 1, 0. So that's why, because this is again, this is true only for the discrete case, not for the continued case. The continued case, it should be probability y less than or equal 10 or less than 10. It is both are correct. Yeah, I will explain that in chapter 4 anyway. So we know that. So then actually you can write the numbers for y less than equal 9. If you need, I can show you probability y equals 0 plus probability y equal 1 up to probability y equal 9. So then use the use the PMF, probability mass function, for each case and simplify. So answer should be 642. Yes, so that's the way we find the probabilities for the binomial. Then how do we find the expected value of this case? Yes, you know expected value of y. If y is the binomial n comma p, expected value is np. So here, what is the n? N is 30, right? N is 30. P is 0.35. So multiply, then we can say 10.5 patients, right? That is the expected value because we are talking about patients. Variance of y, that is what? NP 1 minus p. Then 30.35, 1 minus 0.35. So that is 6.825 patients. But it is not just patient, it is second power of the patient, right? Then standard deviation. Standard deviation of y. That is, NP 1 minus p square root, right? So this is 6.825 square root. So you can say that is 2.61 patients, right? Yes, so that's the way we find the expected value, variance and standard deviation of a binomial distribution.